by the way. I just wanted to toss it in there. I might have to share that with other people.
Yeah, that was super cool. I love the you know, the ease with which you can drop some CSV data in or drop in WMS in. This is Rich.
Okay.
I was curious about the time-dependent stuff you showed there at the end of the chlorophyll. So if you dropped a WMS that had WMS endpoint that had time support, would that just automatically pop up the time slider and stuff, and you could select the time values, or do you need to do some special configuration for that?
No, it should just work, just like you said there.
Yeah. Okay. And what about if it involves also? What if it also involves a height?
So there's no built-in support for the height dimension from a WMS right now. Although
okay.
Yeah, it's something we could definitely consider adding.
Okay.
One thing it didn't show about time is so you can do regions over time as well. So let's say you had the population of Australia, the average level of education in different postcodes in Australia. You'd be playing that out over time, and that was fun.
Yeah, even with the CSV, you can add a time column based on, starting with the CSV stuff that I showed you, add a time column, and then you can have different values over time as well, and you'll get a time slider to play through those.
So you have certain keywords like, I guess these are details, but you have certain keywords like.
Sorry, you go.
These are probably just details, but you have certain keywords like lat, lon, time, and stuff that mean things when you do the CSV.
Yeah, that's right.
We've actually written a guideline that is for Australian CSVs. It just sort of says here are the column headers that you can use, and so we've provided that to government agencies, and the government agencies are now making sure that they create postcodes with the right headings. I mean, in most cases it's blatantly obvious, and the CSV files will work even if someone's never seen the guideline. For example,
right.
Postcode we support POA, or postcode state we support state. It's all pretty obvious, and but we've just put it in a guideline. Sorry.
So we built this system for a purpose here, and I guess we've been working on the National Map project for just under a year. So the point is we've got a lot more stuff that we're building in. We're still under contract with the government here to build a lot of new features, and we're getting new contracts on, like the stuff you saw with chlorophyll, which is a contract with our Bureau of Meteorology. So when you sort of say, can you do this? If we can't do it now, it's probably a feature that may be in our pipeline for development.
Okay.
Any other questions?
Well, I have another question. Or no,
yeah,
sorry, go ahead.
No, my question's kind of big picture here, so maybe you should go ahead.
Well, it's just it was a question about, you mentioned tapping into CCAN and data.gov, and I was just curious if you are doing that. I don't think you're doing that dynamically right through I mean, I guess you could allow in the future, or maybe you already do, the ability to actually do like a CSW search on your data.gov holdings, or maybe a CCAN search or whatever, and then return those endpoints, and of course the viewer being able to recognize quite a different number of endpoints might be able to do reasonable things with them. That would have
what you just did exactly what we're doing. That data.gov.au folder in National Map does exactly that. It uses the CCAN REST API, the package search service to query CCAN live for all of the types of data sets that the map knows how to deal with, and it puts them in a group, categorized in that case by organization, but there are some other options as well.
We also we also have embeddable maps where, so for example, a council can, say Geelong Council, can have a URL that automatically generates a map by going and searching CCAN, turning all the data sets that match Geelong Council, and then creating a custom map on the fly just from a URL. So that Geelong Council needs to do nothing at all to prepare a custom Geelong map. They just put in a URL on the website and they get a custom map on the fly with whatever is the current data in CCAN.
Okay, so it really is really dynamically. So in other words, if someone comes along, they've got a data set, they contribute it to, well, here in the U.S., they contribute it to data.gov, and it's got an Esri REST endpoint in the metadata appropriately identified. It would just show up in the map. It would just show up in the map viewer like this because you're actually querying for all the Esri REST services. You're querying for all the WMAP. Is that what you're doing? You're querying on by service?
Yep, that's exactly right.
Yeah, cool.
Yeah, sounds like a pretty big system to have to set up.
Well, we've got all the pieces already, We've got all the pieces that don't have the viewer like this that can consume the services. I mean, right now on data.gov, like on data.gov right now, there's a very simple web map service that just, anyway. Sorry, I should let somebody else ask some questions.
Well, that kind of leads into my question where I was kind of thinking, I've known about Cesium for some time now, and I feel like there's so many really great applications that we have for this. And I feel like just trying to implement something that's so different than the way we normally already do things is, I've just been running into brick walls every time. I don't know how to, make this, really fit. So.
Well, it wouldn't have to be instead of. It wouldn't have to be instead of, right? It could be in addition to.
It's in addition to, yeah. And not every application would be good for this. Some data is perfectly fine in 2D, but some data could really make a lot more sense in 3D.
Yeah, I guess the way we see National Map and the TerriaJS platform that it's built on is that it's sort of a really accessible way to explore data, right? It's not the client that does everything. It's the client that everyone can use. That doesn't mean we can't build very sophisticated features on top of it, but it's meant to be accessible first and foremost.
In some ways, it's a really cool indexing system to help you discover what data is out there from government, but there's always going to be users who want to download the data and do their own analysis, and that's why we've got these kind of information buttons next to each data set, which gives you hopefully a data URL to download if you're a more technical user.
Yeah, maybe that's the big difference between something like this and the way our national map is currently set up is right now I think downloading data is first and foremost, and being able to view it in a really accessible way is not as easy as it could be. So. Actually,
that brings up a good point, interesting point, that in your map viewer here, obviously you're focused on with web map services, let's use that chlorophyll example. Somebody does that chlorophyll map, they do an animation over time, and then they decide, hey, that's really cool, I want to get that data. Do you have I guess they would just go back to the metadata and see if there's another, data service associated with that data set, or would you somehow help them in that, or do you have plans to do that, or?
Yeah, definitely.
I guess
sorry, go ahead.
No, go.
No, we definitely try to point users to where they can get the data wherever that's possible. So in the simplest form, that can be a link. We got this data from a WMS server. We know there's also a WFS or WCS that gives you the actual underlying data for that map. So we'll try to point people to that. Once you're in that realm, you're certainly you're talking about more sophisticated users, right? Hang on, I accidentally hit play. Yeah, so there's certainly more we can do in that area, and I think we would like to do more in that area. Things like having direct download within the interface based on selecting a region. That's the sort of thing that you guys do in your national map. We're not doing that currently, but it's certainly the sort of thing we'd be considering doing in the future.
Do you have any
Larry, what do you think?
Sorry, I was just going to ask the NICTA team if you guys have any general gripes about working with cesium. It's, you know, I mean, obviously everyone thinks it's really great, but I haven't heard anything bad about it yet.
Well, I'm a little biased. I'm actually one of the founders of cesium. So I helped start the project. I think it's awesome.
But can I just say, I mean, people sort of assume that National Map is based on cesium, but I mean, which it is, but National Map actually works totally fine without cesium, even though cesium is fantastic. Probably about 20% of our users are in government agencies where they're using IE9 or IE10, and they don't have access to WebGL. Sorry. Or they're using old machines that are just too slow to do 3D. And so for them, they use all the features of National Map, and yet you're not using cesium at all. And National Map, in fact, we get rave reviews about how wonderful National Map is from people who've never actually used cesium. Aren't using them. Cesium isn't working under National Map. It's just falling back to leaflet when there's no 3D support. So, yeah, I'm not. Cesium is fantastic. I don't know of any problems in it. Everyone I know who's used it loves it, but we're not actually relying on it.
NICTA's been involved with cesium for probably about 3 years as the second key contributor. So AGI, where Kevin founded the project, is based in Philadelphia, but NICTA from Sydney has been a contributor to that code base for 3 years. So we love cesium.
Does someone else have another question before I cut them off?
What's the relationship between cesium and this Terria?
Yeah, maybe now would be a good time to continue in the presentation, because I'll talk a little bit about some of that stuff. Just a couple more slides here, and then more questions.
Okay.
Thanks.
Great. So, everybody see the WebEx still? See my screen on the WebEx, I should say.
Yep.
So, as we've talked about a little bit now, I guess, we developed National Map as really a brand new application, but leveraging heavily the open source mapping libraries, Cesium and Leaflet. But we quickly realized, even as we were just getting started, that most of the code we were developing was really useful for other applications as well. And in fact, we started developing some of those other applications even before National Map was very far along. So in this diagram, you can see there are sort of these application-specific bits in red, which include things like the configuration of all the available data sources, as well as kind of the branding and appearance of the application. And then there's all this underlying functionality in blue, including 2D and 3D map views, catalog management, and a slick UI. So of course, what we did is we broke the blue bits out into a separate library, and we call that library TerriaJS. So now TerriaJS is used in a large and growing number of applications beside National Map, both within NICTA and some folks outside are using it as well. So there's the groundwater visualization project that allows users to view and understand detailed models of a water table aquifer. There's the REMI project, which is Australian Renewable Energy Mapping Infrastructure. So that provides map-based access to Australian spatial data, which is relevant to the renewable energy industry, mostly targeting folks that are developers, financiers, and policymakers. Then there's Global Risk Map, which uses TerriaJS to understand natural disaster risks and investment and mitigation strategies around the world. This Propeller Aero one is pretty cool. Propeller is a Sydney-based startup that's using TerriaJS to visualize imagery and photogrammetry that's acquired by flying drones or UAVs over construction sites. So that's just a few examples. There are a whole bunch more.
And just on the Global Risk Map, that was just announced yesterday by the UN Environment Program. So that's come through. We've been doing that for a large Australian insurance company, but who are doing it on behalf of the UN Environment Program. So there's a big press release went out yesterday. So that has data from every country.
All right, so hopefully some of that sounds a little bit interesting at least. But let me tell you a little bit about who we are and what we do. NICTA stands for National ICT Australia, where ICT is a British and Australian term for what Americans would more likely call IT or information technology. just to clear that up. So I needed that explained to me. Maybe that's obvious to other people. So yeah, we're actually a nonprofit organization with over 750 staff across Australia, including about 300 PhD students. And through 22 partner universities, a large percentage of students that are getting IT-related PhDs in Australia end up working with NICTA at some point during the process. Our funding comes from Australian federal and state governments, as well as from industry and from contributions from universities. So NICTA is a research organization. We actually publish over 600 research papers per year, but we also have a really strong focus on turning that research into wealth and impact. We do that by collaborating with industry and government, by licensing our technology, and by creating spin-out companies, which then function as independent startups. So we launch approximately one new company every quarter. And we have significant research expertise in machine learning, computer vision, optimization, mobile systems, and software systems. And of course, we also have strong and growing research and engineering expertise in geospatial systems. Okay, so I've used this term Terria a couple times now, separate from TerriaJS, which is a software library. So what is Terria? Terria is a new company created within NICTA with the goal of eventually spinning it out as an independent company that aims to promote and commercialize the TerriaJS library for federated spatial data exploration. So federated spatial data exploration is kind of the forward version of what National Map does. And we're also interested in developing exciting new capabilities for predictive spatial analytics. So what do I mean by predictive spatial analytics? I mentioned NICTA has world-leading expertise in machine learning, and we're leveraging that research expertise to create tools to extract insight, make probabilistic predictions from geospatial data. So an example of that is tools can learn statistical relationships between geospatial data sets in order to predict the statistics for fine-grained geographical regions when only the coarse-grained data is actually available. We can also provide an automated approach to summarizing complex data objectively. So an example of that is learning which areas in a region are most similar to other regions demographically. So Terria, this new company within NICTA, is interested in providing services in these areas. We build rich, usable Terria maps for companies, governments, and others to facilitate spatial data exploration in the way that National Map has in Australia. We also develop custom applications that start with National Map-like capabilities, but then expand into more sophisticated visualization and interaction. And finally, we're really interested in developing and providing these predictive spatial analytics capabilities, especially in the areas of environment, resources, and demography. So all that said, I understand I'm talking to a lot of folks who are developers today or work with developers. And as such, you're probably a lot more interested in how you can use this stuff in the things you're building. So let me tell you a little bit more about the technology that underlies TerriaJS specifically. So TerriaJS includes all of the capabilities in Australia's National Map, everything that I showed you in that demo. And it does so under a highly permissive Apache 2.0 license. So you can use it in virtually any application, commercial or non-commercial. And there's no requirement to contribute your modifications back to us, although, of course, we'd really appreciate it if you did, but you're not obligated to do so. Terria is available as an NPM package. If you're not familiar with NPM, it's Node.js's package manager. That doesn't mean you need to use Node.js on the back end to use TerriaJS. Any back end, even a simple static web server will do just fine. It's actually really easy to deploy. But NPM combined with tools like Browserify and Webpack makes it really easy to manage the dependencies in your web application. So it's kind of a nice environment for dependency management and build tooling, basically. So within the TerriaJS package, individual pieces are highly modularized. It's easy to use only the parts that you need and to leave out the rest. So, for example, if you don't want that menu bar in the top right corner, or if you want something different, you can just remove that code, creates it from the application startup file, and not only will it vanish from the UI, but all the related code will vanish from your built application as well. Okay, now TerriaJS uses Cesium for the 3D view. Once again, I kind of working under the impression that you're all at least somewhat familiar with Cesium, so I'm not going into a lot of detail on that. I do think Cesium's super cool, and I helped found it, so. Yep. Yeah, so beyond Cesium, though, we also, as Bill mentioned, we use Leaflet for the 2D view. So that's kind of a strong advantage of using TerriaJS over Cesium directly. That with TerriaJS, you get a backward-compatible 2D view that works in older web browsers. Okay, so TerriaJS is built by a small and highly experienced team. For example, a couple of years back, I co-authored a book called 3D Engine Design for Virtual Globes, which details a lot of the 3D rendering technology that underlies a virtual globe like Cesium. Another one of the developers on the team developed an application called Collaborative Observatory Visualization Environment, or COVE, which is a visual environment for the oceans, as part of his doctoral thesis at the University of Washington. And we do all of our development in the open on a public GitHub repo, and we welcome pull requests and outside contributors. We really pride ourselves on our agility and ability to respond really quickly to customer needs, and that's enabled, of course, in part by having a high-quality code base, which is something that we're well focused on. But perhaps most importantly, we're passionate about user experience, or UX. We frequently do usability studies with a wide variety of user types, and then we refine our UI and interaction designs through experimentation and iteration. Okay, so let's talk about the specific out-of-the-box capabilities in TerriaJS. First, there's the matter of geospatial data catalogs. So that catalog that you see on the left in National Map, that the demo I showed you before, has to come from somewhere, and TerriaJS offers a whole lot of flexibility in where it comes from. One option is that the catalog can be retrieved from a CCAN server. As I mentioned, CCAN is open source data portal software, and it powers the open data initiative of many governments around the world. The US government's data.gov is a good example of that. And we can populate the catalog by directly querying a certain CCAN server via its REST API, and then we categorize the results that come back from that query by organization, by group, or whatever. And similarly, we can do a REST query to an ArcGIS server to discover all of the map servers and their layers that it knows about. So we can use an ArcGIS server directly as a catalog source as well. And then we can, in the OGC world, we can do a query to a WMS, WMTS, or WFS server to get its get capabilities document and use that to populate a catalog. And then the final option is that TerriaJS has its own simple JSON format for describing catalogs. And a neat feature of that is that subgroups within that catalog JSON format can reference other catalog sources. So it's possible to build a catalog from heterogeneous sources. And you actually saw that in the National Map demo, where different states had different sources. Victoria, for example, is populated from Victoria's CCAN server, whereas others came from querying ArcGIS or WMS servers directly.
And we have just actually written an online editing tool to make it easy to edit a catalog definition, the JSON catalog definition. So we now have the non-technical staff of the Federal Department of Communications using that to manage the catalog.
Also, if you want to populate the catalog from some other source, someone mentioned CSW before, the OGC catalog service. We don't currently have a plugin for that, but it'd be really easy to write one. Just haven't had a motivation to do it yet. Okay, and then there are map servers. We can display raster map tiles from just about any WMS or WMTS server. They work well with open source GeoServer, of course, including using its integrated GeoWeb cache for improved performance if available. We can talk to other conformant, or let's call it mostly conformant, WMS implementations, including the one in Google Maps Engine, MapInfo Server, and the Threads data server that's used with a lot of scientific data sets. And we have great support for ArcGIS map servers, including dynamic layers and Esri's high-performance fused map caches. And we can interface with just about any source of tiles with a simple tile numbering scheme, such as OpenStreetMap's Flippy map tiles, and others use the same scheme. And once again, it's really simple to plug in new types of map servers if one that you need is not already supported. The main requirement here is that the map either be available in multi-resolution chunks or that it be small enough that it's practical to send to a web browser all at once. So in addition to those raster map servers, TerriaJS can display vector features represented in the formats listed here. KML, of course, is extremely popular because it's the visualization format for Google Earth. Our KML support is pretty good, and it's improving quickly as well. Our vector data visualization system is actually based on cesiums. So as I showed you before, vector features need not be simple static points, lines, polygons. They can also be spheres and cylinders and 3D shapes like these. And they can also be 3D models, for example, models of an aircraft or buildings. And just about anything can change with time. Okay, so TerriaJS is essentially entirely a client-side application. It doesn't have a server-side requirement other than a simple web server that can serve up some static HTML, CSS, and JavaScript. It does need one or more servers to get the actual data sets from, of course, but those can live anywhere and can be based on just about any software. But TerriaJS does optionally have two simple services, and it includes implementations of those services in Node.js. One is /proxy, and it's a simple proxy and caching service. It's used primarily to work around the lack of cross-origin resource sharing or core support that we see on some of the data servers that we're asked to connect to. I can go into that in more detail if anyone's interested. Or just a workaround of a common shortcoming we see in some data servers. And that proxy service can also be used to cache data sets, which is really helpful when we're exposing a slow server to a larger audience. Another service is /convert, which uses GDAL or GUDAL, Ogre, to convert a large number of geospatial data formats to GeoJSON for display in TerriaJS. So that service is what helps us display Esri shapefiles here. And these services are optional, though. TerriaJS will work just fine without either of them, as long as you don't need to proxy any data servers or convert any data files. So to kind of pull this all together, I've showed some of you this before, and maybe it's kind of made the rounds, I'm not sure, but I did create a simple TerriaJS-based application populated with all the data sets on viewer.nationalmap.gov. So the link to that is here, and also the source code for it is there. So tech info. I don't know how much time we have left, but I'm happy to answer questions or show you a demo of this USGS map or show you the code in the USGS map, give you a sense of what went into building it, or I guess direct me where you'd like to go from here.
Well, I would love to see the USGS map and kind of what's involved with putting together. I mean, because it's really exciting because it seems like, getting the hands of these sort of clients into more people's hands, essentially, now that we've got all these services and catalogs set up, and having something that can actually consume so many different kinds of services and seemingly not to perhaps add, your own funky service or special service if it's not there already. That seems really exciting. So it'd be kind of neat to see that, like how you did that, attaching to the national map services.
Okay, yeah. Okay. I can show you what it looks like here first. I don't know how it'll go great over the WebEx, but let's see what we get. Everyone see that at all?
Yep. Refresh time is not too bad, but I wouldn't want to do a lot of panning around.
Yeah, right. I'll mostly just turn data sets on and off here, I guess. Yeah, so this is the result of maybe an hour and a half of work to go through the data sets that are on viewer.nationalmap.gov and just look at what Esri map servers it's talking to and add those to a catalog in a custom build of a Terria application here. So you can see that on the left, the catalog is directly reflects what the national map catalog looked like, at least as of when I did this. I don't know if it changes or whatever. But you can explore the different catalogs. You notice there when I opened USGS US Hazards, there was a loading message for a second. That was while it actually went out and did a query to the map server to find all the layers that the server knows about. So our catalog refers to the servers. It doesn't refer to each of the layers within the server. Those are discovered automatically. So I can turn on advisories here. and it shows all the areas that have advisories, and I can click on them, and it tells me this is a heat advisory. It gives me a URL. With a tiny bit of work, I can make that URL clickable or even embed it here or that kind of thing.
Is it possible to exclude, layers then in the catalog if they're automatically discovered? We have run into cases where, we want this service to meet a lot of needs, but it's not just for viewing in a viewer, so we really don't want to show these 5 layers out of that service.
Yeah, that's a good question. In our catalog definition, we have a concept of a blacklist, so we can query the server and say, show me everything that the server reports except for these.
Okay, that works.
You could probably, could you not also probably put something in the metadata that then would be, if you were doing this a custom client, you could then exclude everything that had certain elements of metadata.
Yep, yeah, that's doable as well.
So
by the way, with that blacklist functionality, we use that with all of the agencies and states, or most of the agencies and states. Often, due to performance of particular layers, if there's a particular layer that's where the tiles are not being cached and they're being generated on the fly, that's computationally complex, then we're sort of we actually have performance testing tools that will test all the layers automatically and work out which ones we should be blacklisting.
That's cool.
So yeah, I encourage you all to visit this map on your own systems and play around with it. But maybe I'll switch over to showing you the code that's behind this. Does that sound good?
Yeah.
Yeah, sure. Thanks.
Could you share that URL again?
Yep.
Put it on the chat.
I'm trying to figure out what I'm doing here. Okay. There's the URL. And I'll share these slides with you too, if anyone wants to refer to them afterward.
Yeah, that'd be great. We can send those out to tech stack, or if you want to send them out, you could do that too.
Yeah, so Rich just sent the link in the WebEx chat. I'll switch over to the code here. Can everyone see the GitHub page that just loaded here?
Yep.
I should say. Okay, so this is the code for that USGS map I put together. So the main bits. Let's start by looking at the catalog. So in this init directory here, we have a JSON file. This is the catalog JSON file that I mentioned before. So there's a few things. There's a definition of where the camera starts. There's a list of domains that are known to support cores. So those are ones that will connect to directly rather than going through the proxy. And then beyond that, the rest of the file is this catalog. And this defines pretty directly what we saw in the catalog UI on the left there. So there's a group called base data layers. And within that, there's a US topo availability group, and that group is populated by querying Esri map server. So you can see that the type is Esri map server group. So we can also point to individual map server layers, but this one is pointing to the entire group. So it goes out to this URL, requests all of the dynamic layers within that map server, and displays each of them as an item in the catalog. So that's the pattern that's being used for virtually all of these.
So you didn't, I mean,
did someone get cut out there?
Yeah, sounds like it.
Are there any other questions? Or maybe whoever that was can put their question in the chat.
I've got a question. Is this catalog related at all to like the OGC context package, or is there any kind of translation between those?
OGC context? Is that
there's a kind of a way of sharing a context of data between different clients was the idea.
Okay. I'm not too familiar with that one, but I will check it out.
Okay, well, I'll just check it. Yeah. And then could you actually populate a catalog like this just from a server if you had this in the database and just wanted to?
Lots of ways you can do this, actually. Like this catalog format that we're looking at here, is in this particular app, the code is sort of rigged up to go load this automatically. But it doesn't have to work that way. For example, you can write a catalog file and then you can just drag it onto the map and it'll show up in the catalog viewer.
Okay.
So that's national map to try out different catalog sources. URL that the catalog is loaded from doesn't necessarily even have to be on the same server. So if you had a separate server that was generating a catalog like this by querying a database, you could easily point an instance of a Terria application to that as well.
Are there any other questions, Kevin?
So Kevin, your hour and a half here, it was basically just creating these different entries for like map server endpoints and stuff. I mean, if this was data, if you were pointing at data.gov, I guess you could have discovered these endpoints, right?
Yeah, if these are all in data.gov, that would have worked. I didn't actually try that, but it would be interesting to play around with. So in addition to the catalog, there's actually, I'll show you what the code looks like too. It's pretty straightforward. So this is the entry point for the application, index.js. So there's kind of some, because it's all NPM and browserify based, what we're looking at on this page is a bunch of requires of common JS modules. So these are all the different parts that make up TerriaJS. You can also see there's some cesium parts in here. Okay, here we go. TerriaJS cesium is at the top here. But skipping past all that, you can see the actual application initialization process. And we register all the different types of catalog members, all the different things like that. That Esri map server group, for example, is a catalog member. We create an instance of Terria, tell it the name and who the support email is, and some details about where to find its resources. We start it up, pointing it at a configuration file, which references the startup init file. And beyond that, it's just a matter of creating all the UI elements. So create the actual viewer, create the settings panel, define all the base maps that are displayed, a brand bar with the logo on the top left, the menu bar on the top right, the location and distance legend in the lower right, navigation controls in the top right, the animation control, and then the Explorer panel, which is the catalog now viewing stuff on the left. So it's just a matter of creating all the different components, and they all kind of know how to talk to each other, working around a catalog which can be defined either through code or through external files like the catalog file I showed you, or by querying external servers, of course.